can link. When you do not think, you sink. And when you sink, you stink. Join us at Supreme Success Academy, where we serve as a link to help you get to your peak. You're welcome to another edition of our organic chemistry class, where we shall be taking you on the journey and demystifying the problems that you have with your organic chemistry. So this lecture, we shall be taking you through what we refer to as the homologous series. Now, under this topic, we are expected to attain the following objectives. One of the objectives we would be achieving is we must be able to define homologous series. Then after defining the homologous series, we must also understand what are homologs. What are homologs? Then we'll also be looking at the characteristics of homologs. Homologs are substances that belong to an homologous series. Then finally, we shall be rounding up by explaining the alkane homologous series. So we shall be talking about the homologous series itself. How do we define the homologous series? What are homologs? The characteristics of homologs, as well as the alkane homologous series. So what are members? How do you define homologous series? A homologous series can be defined as a family of organic compounds. The homologous series is a family of organic compounds with a regular and repeated structural pattern in which successive members differ from each other by CH2 or a molecular mass of 14 subunits. The homologous series is a family of organic compounds with a regular and repeated structural pattern in which successive members differ from each other by CH2 or a molecular mass of 14 subunits. So when we say homologous series is a family of organic compounds with a regular and repeated structural pattern, why do we say their formulas are regular and repeated? The reason why their structures are regular and repeated is because of the fact that they have the same general formula. For example, when we look at the alkane homologous series, they have a general formula of CnH2n plus 2. Please take note that the n's here are supposed to be represented as superscripts, as subscript rather, so they are supposed to be written below. Then you have the alkenes. Alkenes are represented by CnH2n. So homologs have regular and repeated structural pattern because they have similar general formula, because of the same general formula. So when compounds have the same general formula, their structure is likely to be regular as well as repeated. So a homologous series is a family of organic compounds, a regular and repeated structural pattern in which successive members, when we say successive members, we are talking about members of homologous series that follow each other. So homologous series is a family of organic compounds, a regular and repeated structural pattern in which successive members differ from each other by CH2 or a molecular mass of 14 subunits. How did we arrive at 14? Let's look at, for example, I have CH4. My CH4 represents methane, while my C2H6 represents hexane. Now, if my CH4 represents methane and my C2H6 represents hexane, let's look at the number of carbon atoms. This is how many carbon? This is 1 carbon atom, and this is 2 carbon atom. When we subtract 2 carbon from 1 carbon, we have 1 carbon. When we subtract 4 hydrogen from 6 hydrogen, we have 2 hydrogen. So this gives us CH2. So it's only applicable to members of our homologous series that immediately follow each other. So this is methane and this is ethane. So the same thing can also apply to pentane, C5H12, this is pentane, and C6H14, this is hexane. So when two compounds, look at this is 5 carbon, this is 6 carbon. 6 carbon minus 5 carbon, that gives us 1 carbon. 14 hydrogen minus 12 hydrogen gives us 2 hydrogen. So this is telling us that members of homologous series that follow each other successively. When we mean successively, we say the ones that immediately follow each other, differ from each other by CH2 or a molecular mass of 14 subunits. So after defining homologous series, as we said, we will now be describing homologues. Now, just the way we talk about members of a family, the members of an homologous series are referred to as homologues. Members of an homologous series are referred to as homologues. So just the way we could talk about a group of we look at the word cattle. When I say cattle, cattle is a collection of what? Cows. So the homologous series of cows is what? Cattle. While the cows themselves are homologues. So homologues are the members of an homologous series. For example, if we say the alkane homologous series, when we talk about the alkane homologous series, in the alkane homologous series we have methane and ethane as homologues. Methane and ethane are homologues because they belong to the same homologous series. You have pentane and propene. These are also homologues. You have hexene, hexyne, and octane. These are also homologues. So homologues are members belonging to the same homologous series. That sorted, we now look at the characteristics of members belonging to the same homologous series. We have said members belonging to the same homologous series are homologues. So if members belonging to the same homologous series are homologues, what are the characteristics that are shared by these members of the same homologous series, known as homologues? Number one characteristic of members belonging to the same homologous series is this. Number one, they have similar chemical properties. Their properties are similar. Please, candidates should be careful not to say that they have the same chemical properties. Their chemical properties are similar, they are not the same. For example, we say they undergo the same type of reactions. For example, look at alkanes. Alkanes will naturally undergo substitution reaction, while alkenes will undergo addition reaction. Alkanes undergo substitution reaction because they are saturated, while alkenes will undergo addition reaction because they are unsaturated. So unsaturated compounds tend to prefer addition reaction, while saturated compounds tend to prefer substitution reaction. However, there are exceptions to this when we look at a compound like benzene. In the case of benzene, even though benzene is unsaturated, benzene still prefers to undergo substitution reaction because the substitution reaction allows it to maintain its benzene. So number one characteristic of homologous series is that they have similar chemical properties. They have similar chemical properties. And what is responsible for their similar chemical properties? This is because of the fact that they have the same functional groups. So compounds containing similar functional groups are likely to have similar chemical properties. Number two characteristic of members belonging to the same homologous series is they have the same general formula. The same general formula. General formula. When I say they have the same general formula, it means that there is an entity that can be used to represent the compound belonging to the same homologous series. Let's look at alkanes. Alkanes, what is the general formula of alkanes? Alkanes, general formula for alkane is CnH2n plus 2. So that means if I talk about methane, ethane, butane, propane, hexane, all these compounds have this general formula because they belong to the same homologous series. So same homologous series is equivalent to same general formula. So let's look at, for example, if I have the alkane homologous series, the first member C1H2 into bracket 1 plus 2. That would mean we have C 2 times 1, 2 plus 2, that gives us CH4. That is methane. If the N is 2, anywhere I see N, I put 2. So what do I have? C, N here is what? 2, H, 2 into bracket what? 2 plus what? 2. 2 times 2, 4 plus 2, 4. This gives us C2H6. And that is ethane. So, number one characteristic of members belonging to the same homologous series, they have similar chemical properties. Number 2 is that they have the same general formula. Number 3 is that they undergo the same type of reaction. They can be prepared. Let's say they can be prepared by similar method. They can be prepared by similar method. So they have a similarity in the method of preparation. For example, if I want to prepare ethane, I can prepare ethane from ethanol. If I want to prepare propane, I can prepare propane from propanol. If I want to prepare hexane, I can prepare hexane from hexanol. If I want to prepare decene, I can prepare decene from decanol. Because the homologous series is the same, the method of preparation will also be the same. Similarly, I can prepare my alkanes by hydrogenation of alkene. So if I have ethene, C double bond C, H, this is ethene, plus hydrogen, in the presence of platinum as a catalyst, we could have C2H6. So this is moving from ethene to ethane. The same method that I've applied there can also be applied in the synthesis of propane. That means propene plus hydrogen will give us propane. So we must understand that aspect of characteristic of homologous series. Then the next characteristic of members belonging to the same homologous series is the fact that they exhibit a regular gradation in physical properties. They exhibit a regular gradation in physical properties. That means their physical properties follow a specific trend that can be described according per group. For example, if I'm looking at boiling points, in the alkane homologous series, let me assume I have a set of compounds like this. Let's assume we have a set of compounds like this. I have C2H4. I have C3H8, C4H10. This is ethane. This is propane. And this is butane. Looking at ethane, propane, and butane, what you observe is that ethane has 2 carbon, propane has 3 carbon, and butane has 4 carbon. Now, following that trend, you realize that the boiling point will also follow that order. That means the boiling point of propane is less than that of ethane, is more than that of ethane, while that of butane is more than that of propane. So there is an what? Increase in boiling points. So in other words, in your next examination, you should understand that the more the number of carbon atoms, the higher the boiling point. The lesser the number of carbon atoms, the lesser the boiling point. However, there are exceptions. We could have compounds having the same number of carbon atoms, yet one has a higher boiling point than the other. What can be responsible for that? The reason is due to branching. So if we look at pentane, and we look at 2-methyl, and we look at 2-methyl butane, They could ask you, between these two compounds, this is pentane, between pentane and 2-methylbutane, which of them has a higher boiling point? The answer is pentane. Reason is because pentane is straight chain, while 2-methylbutane is a branch chain structure, because it is a branch chain structure. So we should understand that members of SOMO, I've given you 4 characteristics of members belonging to the same homologous series. They have similar chemical properties, they have the same general formula, they can be prepared by similar methods, they exhibit a regular gradation in physical and chemical properties. Then you could also take note of the fact that, like I said earlier, successive members of an homologous series that immediately follow each other differ from each other by CH2. So, in the course of our next lecture, we shall be looking at the alkane homologous series. In the next version of this video, once again, remember that your potential is your credential that makes you essential and influential in life. So if you want to be influential, maximize your potential. See you on the other side.